I am Brad Keelor. He is Bruce Kutter. Coming up next on Director's Cut, find out what happens when a 100-ton centrifuge gets dumped in pieces in your backyard. Hello again, everybody, and welcome to another episode of Director's Cut. My name is Brad Keelor. I'm the director of the Geo-Institute, and that is why we call this show Director's Cut. Every single week, I sit down with a different GI member. We have a conversation. They tell me all kinds of amazing things about themselves. Some of the answers are personal, some are professional. All of them are fun. If you don't know anything about the Geo-Institute, after you watch this here interview today, make your way over to geoinstitute.org, and there you will find out somewhere between several and a lot of things about us, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. And if you like what you see today, and I think you will, you should click like, subscribe, get notifications. You could click other things too, but those are the things that you have to click. And we will tell you every time we post something to the YouTube channel. Now our guest for the week, coming to us from very close, if not on, the left coast of America, where he is a professor emeritus at the University of California, Davis. It is Bruce Kutter. Bruce, welcome. Thank you for doing this.
It's great to be here.
We are going to have a great time today. Bruce, you are, of course, one of the winners of the 2025 Norman Medal. We're going to talk about that later. We're going to give you the rest of that centrifuge story that we teased at the beginning. First up, we have two questions that we ask every single guest when they come on the show. Let's start with one of those. Describe your job in 45 seconds.
Well, Brad, I'm retired. So what I do, I suppose my main job now is playing music. You know, I take lessons, I practice every day, and we do rehearsals. And we do a gig at the local winery once a month. Another thing I do is I volunteer to work in the Greenbelt. I do plant native plants in this like 3-acre Greenbelt right near our house. And so I spent a lot of time with that. I spent some time with YOLO Indivisible. It does works on progressive causes, political kind of work around the house. When you get to be my age, which is 70, in about a week, start working on my health. You know, you got to work. This becomes an occupation. I still do some paper reviews. I've helped the Center for Geotechnical Modeling with some proposals, and I give lectures at their workshops once a year. And I always go to the Geotech potlucks. We do, the Geotech group has potlucks twice a year, and the students and faculty all get together. Lately, I've been working on my birthday party too.
I have to tell you, to this 45-year-old, that all sounds really good, and I hope that I'm doing all that stuff in 25 years. I want to ask you about your work with native plants, because you know, we all have that moment when we walk into Home Depot or Lowe's or your local garden center or whatever, and there's a lot of stuff that looks really good there, but you probably shouldn't put it in your yard. What are the top couple of invasive plants that you see, Bruce, in your area?
Invasive?
Yeah.
I thought, let's see. Well, there's so many. Oh, the worst one is vetch. It looks like it grows and covers over everything in these vines, and it grows near our house. It's terrible. We put in things, you know, like a lot of sages, and I put some manzanita and oak trees and other things. That's the good things we put out there.
That is fantastic. I love that. I could talk native plants and invasive
Yeah.
species for days. So we got to talk about other stuff on Director's Cut,
Okay.
though. And the meat and potatoes here are the fun questions, right? I believe, anyway, this is what the people tune in to see. And so, Bruce, we're going to hit you with this one right up front. What's the most ambitious car repair that you've ever undertaken?
Well, I think that has to go back to when I was a teenager. When I was working with my dad, he was an engineer too, electrical engineer, but he grew up on a farm and then moved out to California. And when I was a teenager, we had this 64 Dodge pickup with a slant six engine in it. And I remember going out there measuring compression in each of the cylinders and then deciding some of the, something was wrong. And so we had to take the head off and replace the gasket. But you could go in there and see all the, the valves and check the valves and all that kind of stuff and put it back together. Yeah. So, it was amazing back in those days how you could really look at a car like that and see there's where the gas goes from the fuel pump to the carburetor and then to the intake manifold and then to the, you can see all these things in the fuel line and then the electrical line. And, you can't do that if you open the hood of a car nowadays. You don't know what in the heck is going on in there. So anyway, that was a great experience, but I haven't had time to do that lately because when I was a professor, I spent all my energy working on the experiments and developing the equipment. I got my fix of fixing stuff in the lab. And since I retired now, I have a Tesla and, what can you do on that? I add windshield washer fluid to it. That's what I
I
do.
mean, that's about right. I feel pretty accomplished when I replace the air filters,
Yeah.
because again, there's not a whole lot that you can do now. It's frustrating, but at the same time, I think about all the time I spent in high school doing things. I failed inspection one time because my headlights were too dim, and so I replaced them and adjusted them myself. Even that
Right.
is a huge undertaking now. You wouldn't
Oh,
be able to
yeah.
do that, but rebuilding an engine,
Yeah.
that gets my seal of approval. Good job. So the third question is always the research or practice question. This week is no different. We're going to talk about the centrifuge a little bit later on in the show. We can't have a show with somebody from Davis without talking about the centrifuge. And we're going to talk about a piece of research that you actually won the Wellington Prize for from ASCE, the BART Transbay Tube Uplift. Can you walk us through that? And I mean, maybe talk about your experience winning the award, if there's anything to that too.
Sure. I think it's part of a theme of my research all along, and liquefaction, studying liquefaction with physical models in the centrifuge. We put sensors in there and shake a box of sand with the BART Transbay tube. We actually built the model of the tube itself, the tunnel. It's a cut and cover tunnel that's in the San Francisco Bay between Oakland and San Francisco. And it goes, so it's under deep water in a trench, and they backfilled it with this really loose material, dumped from a barge. It was gravelly, sandy stuff, and so the whole tunnel is buried in that. And the concern was, well, because the tunnel is less dense than soil, what would happen if the soil liquefied? Would it lift the tunnel up if there was another big earthquake, say on the Hayward Fault or the San Andreas Fault? What would happen to that? And so we built a centrifuge model of the tunnel itself. It's kind of shaped and it was about this big, the model of the tunnel. And we did kind of a plane strain study, and we were looking at put pore pressure sensors in there and trying to look at how is the water migrating, because for the tunnel to lift up, something's got to get under it. If you think about the physics of that, you've got something coming up, and something's got to fill that void underneath, and unless you get a vacuum, but that wasn't possible. So what's going to go in there? Liquefied soil, water, whatever. And so we were studying that, looking at migration of water underneath there and how much it covers. But it turned out that, we did this work for BART and with Fugro, and they had done some numerical analyses that said, well, maybe the tunnel won't move very far. It was only going to move maybe 6 inches, and that would be enough that they didn't have to do this huge retrofit that would have cost maybe $50 million or $100 million, depending on how they decided to do it. And they wanted to save that. Based on the numerical analysis, it looked like they maybe didn't have to do it. And so they contracted the work at Davis. And then we started doing those tests, and we pretty much verified that their numerical modeling was reasonably accurate. And so it turns out that, yeah, because of the way the tunnel was placed in the bottom of a trench, it's very difficult for the liquefied soil to flow under it. Okay. It's a very constricted path. And so that limited the movement. I guess that fits in the theme that it came up in a couple other projects, including the Norman metal work, where we were looking at void redistribution and water migration and the failure mechanisms associated with that. Because when soil liquefies, you get water pressures, water moves, and if it accumulates in some zone, that can cause a weakened area, and that can cause slope instability also. So, in a broader context, I think looking at how important the movement of water is during liquefaction came up again and again in the course of my career.
So I do want to ask a follow-up question about that. This from a Washington, D.C. area resident here who may not understand all the ins and outs of everything happening in the Bay Area. What factors were there other than it being in a seismically active zone? Whether it was the material that was used, whether it was, out here, I think sinkholes would be a huge concern in that situation, right? What were the specific geographic factors that were causing some of that risk?
Oh, for the BART Transbay tube?
Yeah.
Okay, so you're going, there's soft bay mud there.
That's what I was hoping for. I'm always up for a bay mud reference.
So there's soft bay mud on one end of the tunnel, and then it becomes harder on the other side of the tunnel. Okay. That's the geometry. The rock is quite deep in that location, so there could be some amplification of the ground motions in the soft deposits. Yep. Just imagine there's soft mud on the bottom. They dig a trench, trapezoidal shaped trench, drop down the tunnel, which was made out of steel. And it has both tubes and one structure. So it's kind of oval like that with two tunnels going through for east and west traffic. Anyway, that's set down there. They just dumped with barges that loose gravel and sandy gravel down in there underneath the tunnel and on the sides of the tunnel. I'm not sure if that answers your question.
You nailed it. That was fantastic. Okay. And of course, we say again, Bruce was a winner of the Wellington Prize for this work, which is a big deal at ASCE. So congratulations. And we'll talk a little bit more about a more recent award that you're about to receive later on in the show. First, for those viewers that are eagle-eyed, and I think that's pretty much everybody, they will notice that behind Bruce there are a couple of guitars. One of them is a acoustic guitar, and the other two are electric basses. Bruce, we can't get through the interview without talking about this. Who are your top 3 favorite bass players of all time?
Well, it's it's pretty hard for me to pick a favorite, but I think I went by influence. I made a list that who's influenced me, and one was, when I was a teenager, Led Zeppelin 1 and Led Zeppelin 2 were huge, and I just couldn't wait for the next album to come out, and we just played them over and over again. I think it inspired us as a teenager, and me and my friends, to form a rock band. And so we formed the rock band, and there was a guitar player and a drummer and a keyboard player. I got stuck with the bass, which I am very happy with. I mean, I really love the instrument now. So anyway, Led Zeppelin made me, I had to copy all the riffs and stuff that, not all of them, I couldn't do all of them, but John Paul Jones did with Led Zeppelin. And then later, when I was in college, I really remember Weather Report and Jaco Pastorius. He's a virtuoso. I love that. And since I've been studying music lately, my teacher, I get lessons online, really introduced me to Ray Brown, and I've been trying to transcribe some of his solos and stuff like that, and really got to appreciate that. He's, one of the greatest jazz bassists of all time. He was married to Ella Fitzgerald, played with Oscar Peterson. He had his own trio. So he was an amazing bass player. Listen to Ray Brown.
Because of the era that you kind of came up during, I have to ask about this. Were you pro or anti prog rock? I mean, because some of the stuff that these guys did, I am sort of a Rush fan, just to throw one out there. And the bass lines especially, you hear these and they're incredibly complex. But it's not for everybody. Where were you on the prog rock spectrum?
Oh, I love that too. Things like Emerson, Lake and Palmer and Yes. I mean, that would go in that category, right? Yeah.
I think so. Yeah. Definitely.
I was into that. Sometimes it was really busy and it made you a little bit nervous and excited, and it wasn't easy to listen to. But I like that kind of music. I mean, I like that. You have to think about it. You can sit and think about it while you're listening. It's not like background music for me, but I love it.
That's true.
Yeah.
It requires a little bit more focus. I agree with you on that one. So that was a little bit of a nostalgia question. We specialize in those on Director's Cut. With this next one, we're going all out, Bruce. You have to think all the way back to when you were a kid or a teenager. What trend from your youth do you wish would come back?
Well, that's a difficult question. I think, when I wish you could understand the trend in those days was like new technologies were happening all the time, but you could understand them. When I was a teenager, they had rocket engines and they were landing people on the moon and stuff like that, but you can understand how a rocket works. I couldn't design one or anything, but you understand the principles. Airplanes, rockets, telephones, even you could see the wires going from house to house, and everything you could understand. So I wish today with the technology, you have, cell phones, social media, artificial intelligence, all these things coming together. And nobody understands how those technologies are going to evolve and affect each other. Maybe they'll help us in some ways, but, since we don't understand those things, I worry that we're going someplace, without knowing what's going to be the end result. Where is AI going to lead us? Nobody really knows, but we're going there, and so I don't know if that's your question stimulated that kind of thought in me. And I don't know. I know you can't go back to the old trend, but I wish we could understand technology like we used to be able to.
I hesitate to compare society to a Disney movie, but every time I see clips or the whole thing, the whole movie, Wall-E, I think I'm a little bit taken aback by it because there are things in there that kind of freak me out. There's the everything in a cup. They have the little screens with them on the chairs that move around the ship at all the times. And it does get a little scary that in some ways we are not that far from that. And eventually there's the battle between the humans and the AI that's
Oh
then
yeah.
controlling the ship. So, but my follow-up question is, I wonder, I was born a little too late to have lived through the meat of the excitement around the space program in the 50s and 60s. Do you feel like some of it is people not wanting to know more? Because I think there was just this insatiable appetite in the 50s and 60s for everything that had to do with space. And people wanted to learn. I don't know when that went away, but I think that has to be part of it.
Mm, yeah. It is really curious. But I think it's more like it's just impossible to understand it nowadays. The technology is so, yeah, it's just gotten, I mean, if you open the car and you look in there, you
Well,
can't,
yeah.
you don't know what's going on inside the car. It's not like that 64 Dodge pickup I was telling you about that you can look in there and see how does everything work. You look in there, oh my gosh, what's going on here? And then you look at your cell phone and, there's so many things in there. How does that work? But I mean, it's not just that. It's just like, how does the screen affect everybody? And how does that screen and all the screen time, social media, and the AI that's coming on there now, and how it's focusing or funneling your thoughts in different directions.
And we're
I
not
don't
going
know.
to know for a long time. That's I think that's one of the more striking
Yeah,
things about it. It could be
yeah,
30
yeah, yeah,
years before we really understand the
yeah,
impacts.
yeah.
We always start the second half of the interview with the other question that we ask everybody when they come on the show. And I guess it's another nostalgia question for you. You kind of got three in a row here, Bruce. How did you first get involved with ASCE and GI?
Um, well, as a undergrad and a master student, I did those at UC Davis also. So I did my undergrad here and then a master's. I was a student member. Then I went to Cambridge, and I was a little bit separated from ASCE while I was immersed in my PhD work in England. But then when I came back, I was then working on the centrifuge facility and heavily involved in the International Society of Soil Mechanics and Foundation Engineering technical committees on physical modeling. I think one other thing I wanted to mention is it wasn't first involvement, but one of the most uh, enjoyable involvements was leading the Geo-Wall team at UC Davis for about 10 years and working with the students. We made it to nationals a few times. We never won, but that was really rewarding. Yeah.
What is the most significant thing you remember about that? I mean, this is a great time to talk about the Geo-Wall because the student competition rules for Geo-Congress 26 are going to come out virtually any day now. And so
Uh-huh.
teams will start preparing and
Uh-huh.
trying to figure out not just Geo-Wall, of course, prediction and the poster competition and all that stuff. But what was the most memorable part of the Geo-Wall involvement for you?
Um, I think um, um, do you know Enrique and Ibuka?
Mhm.
He was a student at UC Davis, and he came up to me and he said, "Bruce, I want to start a Geo-Wall team." So he was like the motivator. We didn't have a Geo-Wall team before that, and so then yeah, he gathered together a group of people and they did it, and they did well in the regionals, but I don't remember how far we went that year. But yeah, no, that wasn't something I remember, how that a group of students, especially one student, just takes up the leadership. And um so it was mostly the students, and Yeah, it was exciting when we did make it to nationals, and we almost won. And then we got disqualified for doing something that I can't remember, but I think we were in first place until we got disqualified, which was, yeah, that was depressing. It might have been partly my fault too, because yeah, there was something I suggested that they do, and there was
Uh,
the fine print in the rules that said you couldn't do something like that.
well,
So anyway,
that's an important life lesson, though, too. And
it
so
was, yeah.
as we do this week's pitch to our viewers, especially all the students out there, the student competition rules for Geo-Congress 26, as I mentioned, will be up any day. Watch the website for those, and I guess pay attention to the fine print in the
Yeah,
rules
there you
so
go.
that when you compete, you make it all the way through without incident. We have
Yeah.
another music question in here for you, Bruce. And this one was kind of inadvertent that I stuck this one in for you. But I've always kind of longed to have walk-up music. You go to a baseball game and every batter has their own thing or whatever, and I always think, well, if I had a song played every time I entered a room, what would I want it to be? So for you, Bruce, if you had a song played every time you entered a room, what would you choose?
Well, if it was the same song um, in every room, or yeah, that would be something that you would have to hear many times, and it would have to be interesting. So I decided that I would have to pick a jazz standard because I'm assuming maybe I would be cheating the fine print of the rules. I don't know about that, but I don't know what the rules are about this. But there's so many different versions of that song. Chet Baker, Frank Sinatra, Doris Day, Diana Krall, or Nat King Cole. All these different artists have done that song in different ways. And so if you go in the room, I could hear different versions of the same song. I think that would satisfy the rules. And
I
that's why
really like that.
I would pick a song like that because there's so many different versions of it.
So I mean, it's director's cut, so really you make the rules.
Okay.
There are no rules, but I feel like that's a solid pick because one of the things I'm always amazed by, well, these guys could change the music anytime, I guess, but I think to myself, do they really want to hear this song 650 times this season every time they come up to
Uh-huh.
bat? I feel like
Uh-huh.
it would get old pretty quickly. Um, so I mean, I'd probably go with jazz too because of that, just because it's more interesting. I don't
Yeah.
know, or it would have to be something that pumped you up. I think
Yeah.
that would be the other way you could get around it, but I feel like you made a good
Yeah.
choice.
Well, it depends on if you want something to pump you up, yeah, or if you want something that just helps you relax
Well,
or
that's true
helps
because
you.
you're
Yeah.
gonna walk into rooms at midnight on weeknights
There
sometimes
you
too,
go.
and you probably don't want to be pumped up for that.
Yeah. Yeah.
The question we teased all the way back at the beginning was, of course, about the centrifuge. We cannot have a Davis conversation without the centrifuge. This is a little bit of a special one because the centrifuge is at Davis, kind of because you were there and you brought it there, Bruce. So my initial question was, what does it take to move a centrifuge? And then we want to talk a little bit about how it shaped your career. So can you tell the story of how it got to Davis in the first place, and then about your work over the years with the centrifuge?
Yeah. Um, I thought I should say why centrifuge. Maybe some people aren't that familiar with the centrifuge, and I'll just do that
Go
the
for it.
basic spiel about that. And that is that we want to do physical modeling, do physical experiments and look at how you could build accurate models. And one thing that really helps the similarity of the models is to get the stresses right, because the strength and stiffness and dilatancy of soil depends on the stresses. So if you're going to do a model, how are you going to get the stresses right? Say the model is a foot deep. if we spin it on the centrifuge 75 Gs, you know, the pressure's increased 75 times. So the pressure now is like 75 feet deep. So now you're talking about real geotechnical scale problems, like the BART tunnel could fit, you know, in a 75-foot depth with, you know, some soil underneath it. Anyway, so the centrifuge itself gives you the pressure. It gets the pressures right, the effective stresses right. But then we put a shaker on the end of the centrifuge to simulate earthquakes. And so while it's spinning around, we're shaking it to simulate the shaking of the earthquake. That will cause liquefaction or something. Anyway, so that's why a centrifuge. Now, why a big centrifuge? We have a 9-meter radius centrifuge because we want to build, you know, good sized models with many layers in them, and you need a big deposit, you know, a significant depth if you want to put multiple layers of different sands and gravels, or, you know, coarse sand and clays or whatever. And you have details like the tunnel. So we need a big centrifuge for some experiments. So we said, well, let's get one that's 2 meter, a model that's 2 meters by 1 meter by half a meter deep kind of thing. It weighs tons. We built a centrifuge that is 9 meters in radius. Anyway, now that you kind of got an idea, I hope, why centrifuge. Did I do that okay, Brad?
It was great.
Okay. And then, so then physically, what happened? So I was undergrad here at Davis. Or I think I had already started my master's at Davis. And then Davis proposed with NASA to the National Science Foundation to build this National Geotechnical Centrifuge. And when I was an undergrad, they were just working on the proposal. And so I got the opportunity to meet all the muckety mucks. I don't know, Dick Woods and Bob Whitman and others were on the review panel for NSF, and they came out to Davis. And when I was a master's student, I got to show them whatever research I was working on in my master's. And then I left and got my PhD in Cambridge. And then when I was away, you know, I was over there for 4.5 years in Cambridge, and I got trained to use a centrifuge by, you know, people like Jimmy James and Andrew Schofield, and part of my research over there too was to build a shaker on their centrifuge, and we came up with this idea called the bumpy road shaker. I didn't come up with that. That was Andrew's idea, and I can explain that, but I think I don't have time right here unless you want to follow up on that. Why is it called the bumpy road? That's another teaser for the next one. Anyway. Let's see. So I worked with Philip Turner. He was a great design engineer. He worked in the auto industry and had many patents, but then he became he retired from that after he'd made a fortune, and he was working in Cambridge, and I got to work with him on the design of this shaker in Cambridge. So he did all the, you know, he was a pro at design. But I got to go and check his design and run some numbers and suggest some modifications and build the model, design the model container. So that was part of my PhD project in Cambridge. And then I looked at the response of clay embankments and earthquakes. But then when I finished my PhD, lo and behold, the centrifuge in Davis was almost ready to start running. You know, it was built and it was in place, and we were going to do the proof tests any day now, according to, you know, I better hurry up and finish so I can get over there and help run it. Then I came to Davis. I got hired as the managing director, an adjunct professor in Davis, and was working on getting this thing ready for research and getting it ready for proof tests. And then about a year after I arrived, everything took longer than we thought. We were doing some proof tests on the centrifuge at NASA Ames Research Center. So now this centrifuge was an NSF proposal funding NASA and UC Davis. Davis was supposed to be run the research. NASA was running the facility and building the facility and operating the facility. So it was like three organizations working together with NSF, NASA, and UC Davis. So by this time too, the centrifuge was sharing a power supply. Oh, I didn't mention one other thing, and that is that the centrifuge, why did it go to NASA? Why would you build a geotechnical centrifuge at NASA? And it was because they had a centrifuge there before, and it was for Apollo takeoff and landing. And that centrifuge was was decommissioned. What do you do with this empty centrifuge building? Oh, somebody heard about geotech, and that's why they worked together with Davis to put together a proposal to reuse the building and the power supply and the motor at NASA. So by the time I got there and we were actually testing the centrifuge, now the power supply was being shared with another facility called the Vertical Motion Simulator at NASA Ames. And so we ended up doing the proof test of the centrifuge in midnight. It's like night shift, because they ran that thing 2 shifts, the motion simulator, training pilots and astronauts to fly stuff. So we got to do this at midnight. We go there for the proof test, we spin up, and we're going maybe at about 20 G, and all of a sudden the fire alarms go off. And all the lights flash, emergency shutdown, we stop. And look there, and the motor bearing had failed. So this is the motor that was part of the old centrifuge, right? We were reusing the motor. The motor bearing failed, it dropped down, and there was a lot of arcing damage to the gearbox. And so we have this broken gearbox and broken motor. Centrifuge is fine. Centrifuge didn't get hurt itself, but these other equipment was broken. And so then NASA decided they didn't want it anymore. And so they just put it in trucks and hauled it up to Davis.
Wow.
And dumped it in the field on blocks. It took several trucks, because the arm weighs like 100 tons. The smallest or the biggest piece weighs 100 tons by itself. And then there was a couple of trucks that were hauling the stuff. And then they dumped it there. So then what do? I'm an assistant professor. I don't have tenure, and I came out here to work on a centrifuge, and now I have this stuff in the middle of the field. Anyway, so that was pretty traumatic for me. But I worked with Professor Cheney, was the director. He's the one that hired me, and he cobbled together money from Tyndall Air Force Base, Los Alamos Labs, and other places. NSF didn't want to give us more money right away because of this, bearing failure. We had to rebuild our credibility with NSF. And so we got money from other sources and got the thing spinning. We spun it at 18 G, but it was actually first spinning in the open air. No building. We could afford to put a concrete foundation down there, put the building there, and get a used motor from the oil fields and a used gearbox that was used for drilling oil wells.
Wow.
We put it there, and it happened to, we were able to get the thing going at 18 Gs in the field in Davis then. And then we did get another grant from NSF to put a building around it. That reduced the wind resistance, and we got up to 48 Gs. And then Professor Idris came, he was hired. I was still an associate professor then by this time. And Professor Idris was the director of the Center for Geotechnical Modeling after Cheney. And we got this good-sized grant from Obayashi Corporation in Japan to build a shaker. And I spent a lot of my time, several years then, maybe 3 or 4 years, designing and building that earthquake simulating shaker. And then a similar design was adopted at RPI and University of Hong Kong and other places. But then we started doing some research on that. Now we can go up to 50 Gs, and we could have a shaker on the end of it. So we could do, the good liquefaction studies, and that's when we did that work that won the first Norman medal on the void redistribution and the lateral flow slides in the centrifuge. Yeah,
that is amazing.
I guess then that's pretty much, then came NEAS. We got the NEAS, the grant for the shared use, continued regular funding every year to support the staff and keep the facility going and make it available for shared use under NEAS and NERI. And Ross, Dan Wilson, Ross Boulanger, and Jason DeYoung have all taken care of the centrifuge since I retired, or since I stepped down from director at about, it must have been like 15 or 18 years ago. So this took me from assistant professor all the way through my career. After Ross took over, I got to just use the equipment for a while, and so that was awesome.
Fantastic. We've never walked all the way through that story before, so that was amazing. I think partially because you were the person who was there during that whole time. And I kind of want to segue right into the next question because of that. So you were at Davis for 2 of your degrees and then went to Cambridge, and then you came back. The way I had phrased this question was, what made teaching at Davis your dream job? But I didn't actually ask you if it was your dream job before I wrote that. You've spent almost your entire adult life there. So is it your dream job? Why did you come back in the first place?
Yeah. No, it was my dream job. I mean, that's why I stayed my whole career. I think there's three things that, one of them is the fact that this is where I grew up too. I mean, how lucky is that? My family is 50 miles away, and I grew up 50 miles away. In Placerville area, up by Coloma, where they discovered gold. And I did my undergraduate at Davis in 75 to 78. So I had lots of friends and family around here. Up and coming civil engineering department, it was the College of Engineering is only established in 1962. So it was pretty young. I did my undergrad there, 75 to 78, my master's in 78. And so there's a pretty young faculty at that time, and really good people. And so it was 42 years ago that I joined the faculty. And of course they had the big centrifuge. I was perfectly trained in Cambridge to do it. And so everything fell into place, even that collapse down in NASA, at NASA Ames, that they delivered the centrifuge to us. And so now, instead of having to drive all the way down to Palo Alto to use the centrifuge there, we have the centrifuge in Davis. So I don't know, everything fell into place. And even the things that seemed terrible ended up working out. So I guess, yeah, that's why it's my dream job.
That was fantastic. And again, thank you for walking through the whole centrifuge story there. And it paired up perfectly with your response to that question. I couldn't have asked for more, Bruce. I told you this was going to be a good one, and it is. We got one question left. You are one of the winners of the 2025 Norman Medal. If anybody goes to the page on the ASCE website that talks about the Norman Medal, it says something like that this is the highest honor, the biggest award you can get for a paper, for a manuscript under ASCE. It's a big deal. Then you look at the list of award winners. It goes back, I think the first one was 1874 or something like that. You go through it, amazing names through the history of civil engineering on this list. And then you start noticing there are a few that appear multiple times. Wayne Clough, I believe, is a 2-time winner. I think Dave Daniel might be a 2-time winner. Then you look at people like Carl Terzaghi. Carl Terzaghi won it 4 times. He's the only person to win it 4 times. There are not a whole heck of a lot of people who have won it twice. Bruce, this is your 2nd time. Has it sunk in yet that you're on this short list of 2-time Norman Medal winners?
Well, maybe. I don't know. I thought when I first started thinking about this question, I thought, yeah, it sunk in. But I don't know. When I started thinking about the answer, I'm not sure if it still is sunk in. But I do need to say that really something like this is a team, and there's excellent colleagues and all the staff at the center and the co-recipients of the awards, both of them. One of them I got with Ross and 2 students, Eric Malvik and Kula Singham, and another one, the recent one was with Katerina and another student, Sumit Sinha. And so, and all the staff and everything, but, all the people that work at the centrifuge and make things possible, and all the colleagues that we talked about this research before. So, I really appreciate the recognition from ASCE, and especially all the awards committees, in the Geotechnical Institute. I know it is so much work to do the evaluation of these papers and stuff. And so I really am grateful to everyone that spent the time to study my work and try to understand it. To be honest, the first one was super important to me because it came when I was struggling with that facility in the early years, and it was sitting in the blocks out there and not working, and then finally got it going, got the shaker and struggled to get that going. And then we did the work, and then I got the prize. Because before that, I really struggled for my first promotion, People might look at me and say, oh, he's so successful, whatever. But when I was an assistant professor, it wasn't easy. And getting something like that first one made a huge difference. So for me personally, the consequences were more for the first one. But then when I looked at the list of all the people that had won it more than once, and I'm thinking, wow, I don't know if that sunk in. Anyway, yeah. So anyway.
We owe you a huge congratulations, and Bruce and Katerina and Sumit will be on hand at the ASCE convention in Seattle in just a couple of weeks to receive the award in person. We have to give a huge shout out to Katerina on this one too. I believe she's only the 3rd woman to receive the award in its now 150-year history. So that is a monumental achievement as well. I'm happy that I'm going to be there with you guys when you receive the award. Yeah. That worked out really well this year too. So again, a massive, massive congratulations. Bruce, you made it through all 10 questions. You made it through the follow-ups. We got the whole centrifuge story for the first time in the history of Director's Cut. I feel like we can plant the flag and call this one a success. For all of our viewers, if you liked what you saw, and I'm assuming you did because you're here at the end, again, you should click like, subscribe, and get notifications. And yes, we will let you know every time we post something to the YouTube channel. Bruce, thank you again for all the stories, all the tales, and all the great answers today. This was a lot of fun.
It was my pleasure.
And again, for all of our viewers, it'll be just 7 days before you see us with another brand new episode of Director's Cut.